The ANSI trip curve for FPE NK frame breakers consists of several key elements. These elements are low magnetic pickup, short time, long time, and instantaneous trip. Understanding these characteristics is crucial for properly applying and troubleshooting these breakers. The exact trip curve may vary slightly depending on the specific model and manufacturer. The low magnetic pickup, abbreviated LMP, is typically set at 70% of the long time current rating. The short time characteristic, abbreviated SD, starts at 2 times the LMP or 140% of the long time current rating. It decreases linearly to 6 times the LMP, which is 420% of the long time current rating at 0.25 seconds. The long time characteristic, abbreviated LT, is represented by a straight line parallel to the x-axis. It is typically set at 100% of the breaker's rated current. The instantaneous trip, abbreviated INST, is a vertical line at 12 times the LMP, which equates to 840% of the long time current rating. Let's consider an example trip curve for a 600 amps NK frame breaker. Firstly, the LMP is 420 amps, which is 70% of 600 amps. Secondly, the short time characteristic starts at 588 amps, 2 times the LMP, and decreases linearly to 2520 amps, which is 6 times the LMP, at 0.25 seconds. Thirdly, the long time characteristic is 600 amps. Fourthly, the instantaneous trip is 5040 amps, which is 12 times the LMP. The trip curve is designed to protect the breaker from damage caused by overcurrents. The actual tripping time may be slightly shorter than the trip curve indicates due to manufacturing tolerances. It is important to consult the manufacturer's specifications for the specific breaker model being used. These curves are crucial for ensuring the protection of electrical systems. Breakers are designed to interrupt fault currents and prevent damage to equipment and personnel. Understanding the interplay of these different tripping characteristics is vital for proper coordination and selective coordination in electrical distribution systems. Selective coordination ensures that only the breaker closest to the fault trips, minimizing disruption to the rest of the system. When evaluating an existing facility, it is crucial to understand the specific settings and characteristics of the installed FPE NK frame breakers. The provided trip curve information serves as a general guideline, but consulting the manufacturer's documentation is essential for accurate application. The information presented should be used in conjunction with proper safety practices and qualified electrical personnel. Working with electrical equipment can be dangerous, and it is crucial to follow all applicable safety codes and regulations. Here is a further breakdown of each characteristic. Firstly, the low magnetic pickup setting determines the minimum current level at which the breaker will begin to respond. This setting is crucial for avoiding nuisance tripping due to temporary overloads or inrush currents. Selecting the appropriate LMP setting is critical for balancing protection and operational reliability. Secondly, the short time setting allows the breaker to ride through short duration overcurrents, such as those caused by motor starting or temporary system disturbances. The inverse time characteristic of the short time setting provides coordination with downstream devices, allowing them to clear faults before the main breaker trips. The shape and duration of the short time curve are important considerations for system coordination. Thirdly, the long time setting provides protection against sustained overloads. The breaker will eventually trip if the current exceeds the long time setting for a sufficient duration. The long time setting is typically coordinated with the thermal capacity of the protected conductors. Fourthly, the instantaneous trip setting provides very fast tripping for high magnitude fault currents. This setting is designed to minimize damage to equipment and prevent the spread of faults. The instantaneous trip setting is typically set above the peak let-through current of downstream fuses or breakers. When testing FPE NK frame breakers, it is important to use appropriate test equipment and procedures. Insulation resistance testing, contact resistance testing, and timing tests can all be used to assess the condition and performance of the breaker. Trip curve verification testing can be performed to ensure that the breaker is tripping within the specified tolerances. Accurate documentation of test results is essential for maintaining a reliable electrical system. Safety should always be the top priority when working with electrical equipment. De-energizing circuits before working on them, using appropriate personal protective equipment, and following lockout-tagout procedures are essential safety practices. Qualified electrical personnel should perform all testing and maintenance of FPE NK frame breakers. Consider the application of these breakers in various scenarios. For example, in a motor control center, the FPE NK frame breaker might be used as the main breaker for a group of motor starters. The trip curve would need to be coordinated with the motor overload relays to ensure that the motor is properly protected. In a distribution panel, the FPE NK frame breaker might be used to protect a branch circuit feeding a critical load. The trip curve would need to be coordinated with the downstream breakers to ensure selective coordination. In a service entrance, the FPE NK frame breaker would be used to protect the entire electrical system from overcurrent. The trip curve would need to be coordinated with the utility's protective devices. The selection and application of FPE NK frame breakers should always be based on a thorough understanding of the electrical system and the applicable codes and standards. Regular inspection and maintenance are essential for ensuring the continued reliability of these breakers. The low magnetic pickup, short time, long time, and instantaneous trip settings are critical parameters that must be properly configured for each application. Consulting the manufacturer's documentation and working with qualified electrical personnel are essential for safe and effective use of FPE NK frame breakers. The coordination of these settings with other protective devices in the system is crucial for achieving optimal system protection and reliability. Remember to prioritize safety and follow all applicable codes and regulations when working with electrical equipment. In summary, the FPE NK frame breaker trip curve provides a visual representation of the breaker's response to overcurrent conditions. Understanding the low magnetic pickup, short time, long time, and instantaneous trip characteristics is essential for properly applying and troubleshooting these breakers. Consulting the manufacturer's documentation and working with qualified electrical personnel are essential for safe and effective use of FPE NK frame breakers. Testing, maintenance, and safe practices should be observed at all times when dealing with electrical equipment. Proper selection of settings and system coordination are also critical.